Good morning. My name is Wojtek Kaczynski. I'm here to tell you a little bit about an Australian project called the Australian Characterisation Commons at Scale, which has a very strong microscopy focus. The project itself is quite a large-scale project run across a number of institutions and peak facilities in Australia. So the program of work is an infrastructure project, research infrastructure project, which is to develop a characterisation commons for Australian imaging researchers. And characterisation in Australia really means imaging, microscopy, and other techniques that are used to look inside materials, look inside biological materials, physical materials, and so forth. Very strong focus on imaging, but not just imaging. The project itself is developing a rich ecosystem of computing systems, data repositories, workflows, and services connected with instruments. And it has three specialized programs. And the largest of those is one specifically on big data electron correlative microscopy. But it also includes a focus on biomedical imaging collections and scattering as a technique as well. The project is partnered with Microscopy Australia and National Imaging Facility. It's a very distributed project across Australia. So we're about 15 staff members in total across a number of facilities at a number of universities in Australia. And they all have specialised requirements, specialised instrumentation, and they've made an investment into this project to see its benefit. The development team of the project itself is also quite distributed across Australia. And that affects what we do and how we operate as well. And it does impose challenges, but it also means that we at an Australian scale are able to work together quite effectively and leverage each other's expertise, leverage each other's centres of excellence and so forth. So how are we building this platform? Well, we're deploying tools and services across 4 nodes in Australia. This includes rich online desktop environments and also web-based tools. We're helping improve interoperability between some of these capabilities. We're integrating flagship instruments, so integrating flagship instruments with the cloud infrastructure or the high-performance computing infrastructure or the data management infrastructure that they need. We're building research community around us, around our services. We've got a specific training program, and we have a dedicated sustainability program that's working with institutions to ensure that the tools that we take up are actively run beyond the end of the life project. This is the diagram of the project itself. It's very complicated. It has 3 major parts, though. It has infrastructure. You can see these 3 major parts around the outside of the diagram. It has an infrastructure program. It has a number of work packages that are modality specific that I mentioned before, and it has a management and training program. And they all contribute into the center here to build the characterisation commons. And the characterisation commons itself is built up of software repositories and includes code repositories as well. Web native applications running in the cloud and available to Australian researchers, and also hundreds of POSIX applications that we're making available through remote desktop environments. And finally, also data collections and data repositories. And so all of these are, in as much as possible, interoperable and accessible to Australian researchers. The infrastructure program itself, let me just show you a little bit about what that does. So we develop a program called the Characterisation Virtual Laboratory, which is really an environment that we provide over the top of research cloud environments and over the top of high-performance computing facilities to provide interactive access and to provide a rich suite of tools and services for researchers. So our overarching goal is that any researcher in Australia will be able to quite simply log on, use these tools and services, and have really, a very, very simple set of steps to get on and to use some of these capabilities. This environment has been in development for some years. It runs in Melbourne and Brisbane already in production, and has probably coming up to close to 1,000 users, and around about 300 or 400 active users any particular month. But we are deploying it further across Perth and Sydney over the course of the project itself. It supports a range of tools in a whole wide range of different domains and modality areas. And it's integrated with a number of data management environments as well. Increasingly, we're also supporting development environments and notebook environments such as RStudio, Jupyter, and some machine learning toolkits as well. And that'll be coming over time. Let me tell you a little bit about the big data producing EM and correlative program of work, which I think will be of most interest to this particular community. So to explain this, let me talk to you a little bit about one particular use case that we're addressing, and that is cryotransmission electron microscopy, cryo-electron microscopy, particularly single particle analysis. This is a relatively simple workflow: sample preparation, capture, processing, and structural determination. Under the bonnet here, it is, of course, much, much more challenging, obviously with regards to the science of sample preparation and the data capture as well, and the experiments that are involved. But in particular, with the informatics side, some of the challenges here that we experience are the capture of metadata at the experiment, the sheer scale and size of the data sets that are required to gain good samples. We sometimes deal with 5, 10, 20 terabyte data sets. The amount of processing that's involved with regards to these sort of techniques is quite significant, despite the fact that it accelerates very well on GPUs. And the long-term data management, particularly now that we are under requirements to store and keep data for around about a 7-year period, this is quite a burden for a lot of facilities. And there is a significant amount of potential for metadata or provenance to be lost in this process as well. And this is the workflow that we use at our high-performance computing facility called Massive to manage this data from instrument through to publication and archive. It is a relatively complicated process, and we're quite well set up for it. But what we really want to do is automate some of these steps, and automate them not just at our own high-performance computing facilities, but make that available to other high-performance computing facilities in Australia to help them underpin electron microscopy processing. This is relatively new work. So the actual project itself has been operating for under a year, and many of the staff members involved have really only been involved for about 6 months. One of the first things that we did in the EM part of the project was to undertake a fairly large discovery exercise to really tune what we were going to do over the course of the project. So to do this, we've actually talked to quite a number of core facilities across both Australia and the world. And we asked them, what are the challenges with regards to orchestration and management of data generated by big data electron microscopy instruments? So we produced this discovery report. It is available publicly. It's just been published on Zenodo very recently. And I do encourage you to download it and to examine it yourself. It is a very good resource with regards to some of these challenges. So, fundamentally, what are the challenges? What are the best practices with regards to some of things like moving large volumes of data efficiently, which tools and infrastructure are appropriate, how other facilities are storing data, and what are the opportunities for automation across this domain. So one of the very first, very simplest things we're doing out of this discovery report is that we're installing Globus across microscopy facilities in Australia. So Globus is a tool that enables data transfer efficiently, securely, and reliability between distant sites. So it's It's a service that you subscribe to, which provides data transport services. So end-to-end data transport services that'll restart, that provide parallelization across long-distance networks and so forth. And this is a huge advantage to microscopy facilities in Australia to have this service available to them, so that they can move fairly large quantities of data between themselves for analysis, for processing, for archiving, and so forth. And another one is the deployment of data management across key facilities. One that we're investigating first is the Clouder package. It's a customizable and scalable management framework that supports many data formats and multiple research domains, has quite good search capabilities and automated metadata extraction. And it has a particular focus through a project called 4Seed that focuses on material sciences. We're currently testing that and deploying it at the University of Queensland, specifically for the cryo-electron microscopy community. We are also doing an amount of work on biomedical imaging collections and analysis, and this is really on making a number of major collections available to researchers in Australia and close to their processing. I'll flag that one thing that we're doing is specifically looking at the image data repository, the IDR, as a library that we'd like to perhaps mirror, if not all of it, then subsets of it within Australia. So thank you. There is quite a large project team involved in this work, and in particular with regards to the big data electron microscopy capabilities that I've presented here. David Poga, Jay Van Scheindel, Huang Nguyen, Chris Myers, and Joshua Silva have been very involved in that work. Thank you very much.